Hey everybody, welcome back. Mr. Swirsky here, up for our second lesson. We're talking about segment addition and midpoint stuff. So let's jump right into it. If we just look at this in general and we kind of look at our situations here, the first four, and we're looking for our missing piece. So we're looking for here, for this, for that, and for this whole thing. Should be able to kind of deduce that this whole thing is going to be when I'm adding those two, so I'm going to end up with 22. If I want to find this, I'm really just subtracting 29 from 19, so I'll get 10. 81 and 39, I would end up with 42. Adding them together will give me the whole thing, and then when I add all of this together, I'll get 34. So all of those are kind of the basics for segment addition. If you can do that, you've kind of got the basics for that. So let's just get a little formal definition on there. So segment addition is just saying this, is basically saying the parts of the line make up the whole. So when I combine this and this, I should get the whole darn thing. That's where it's saying Rx, so that's this first piece and the second piece. So it's 1, 2, equal the third, equal all of it. So any of these three parts, Rx, XS, or RS, those three pieces could be missing. So then I'd have to use some algebra to be able to find the other piece that isn't available. And I can just use the other two parts to figure out which one that means, either adding or subtracting. There's only two options, which hopefully makes sense to you. Now we have a special case when, let's say that that X value, where in this case it was a little off to the side, or it's just at some point on the line. Well, let's say that value X, or the point X, ends up right in the middle, and that's what's called the midpoint. Okay, or it's also what we would say is the bisector. So X is the bisector of RS, and that's halfway in between the endpoints. Now we also name that as congruent. This is the symbol right here and right here for congruent. We use that equal sign with the little squiggle on there. And for the life of me, I can't remember the official name for it, but that's the congruency sign. And we can also symbolize that by simply just putting some ticks and saying that this and this are the same. That's why we symbolize it. If we had more than that, we could also use 2 ticks. But as long as we have the same symbol, that means that they're both the same thing. And we would actually be able to set those equal to each other. So if I have these and I know that they're congruent, either by symbols or by being told, I know that Rx and XS are the same thing, or I can set them equal to each other. And that's going to be kind of our goal. So those are the two pieces with segment addition. We can either have one piece, so we got to add them together, or we can set them equal to each other and solve. Okay? So if we look at something like this, because I have the congruency symbol, I know that they're going to be the same thing. So if the first part's 6, I know the whole thing, that's 6, which means the whole thing ends up being 12. And if I know this is the whole thing's 22, I know that each piece has to be 11 because it's congruent. Okay, so why don't we try this? Now we're going to plop in some algebra. So think about, am I going to be setting it equal to each other, or am I going to be adding them together? Try that out and we'll come back. All right, so we have 2x minus 6, x plus 7. The giveaway is here and here. Those are congruency symbols, so I need to set them equal to each other. 2x minus 6 equals x plus 7. Now we're just, oh, that's a bad 7. Now we're just doing basic math. X, bring this over, and we got 13. We're just finding the value of x. I could plug it in, and I could actually figure out what this whole thing is. If I plug it in for x, this will be 20. 13 times 2 is 26. Minus 6 is also 20, which makes sense because they're congruent. Okay, next one. Why don't you go ahead and give this one a shot, see if you got it. Remember, am I going to add them together, or am I going to set them equal to each other? All right, because there's no congruency sign, these together, so this and this are going to equal this whole thing. So that means I have to set it equal. I have to say that this 2x minus 6 plus, so that's the first piece, x plus 7 is going to equal, that's the second piece, 34. Now I can combine my likes and solve. So I'd get 3x, plus 1 equals 34. And, oops, that's a terrible 4, sorry. 3x, we're just going to finish this off, 33. So let's bring it all the way up here. X equals 11. That's where we should have ended up. And again, I can plug that in and solve if I really wanted to. I could say that I know that this would be 18 if I plugged it in, and this would be 16. Okay, give it another shot, see what you get. Because this is congruent, I know that they have to be set equal to each other, so I'd be 5x plus 13 equals 5 minus 3x. It doesn't matter what's set up on there. We know that they're congruent, so then I would just go through the process of solving. So I should end up getting FG, which is the smaller one, is 8, and then FH, which is the whole thing, would just be double, so I get 16. And again, let's see what we get. Remember, decide, are you adding them together and setting equal to the whole thing, or are you setting them equal to each other? Okay, in this case, because they're not congruent, I'm saying that these two things together, oh, that's a plus, I want minus. Minus 2x plus 4x plus 3 has to equal 20. Now I combine my likes. I'm not gonna kind of waste your time here. We should end up with a grand total x equaling 1, which means if I plug it back in, we should get UV at 13 and VW at 7. Combining those gets me my 20, which is what I'm looking for the overall. Okay, now we have a situation but no picture. So the biggest thing that I can tell you is to draw a picture, please. It's going to help you be able to see what's going on instead of trying to guess or assume. Okay, now in this whole thing, it has nothing to say about congruency, so I can't assume that it's congruent. So I know that HJ, which would look like this one. So here, let's just make a drawing. So here's H, here's J, K is between them, but I don't know if it's where it is, so I can't assume it's congruent. So I know that HK is 8x minus 6, KJ is 9, and the whole thing, HJ, is 11x minus 9. Okay. Now that I have that, I should be able to look at that, set it up, and solve. Why don't you give that a shot? Oh, actually, we're going to do that together. I'll give you the shot on the next one. So let me actually put all that. So we should get, when I do that, there's no congruency, so it would be 8x minus 6 plus 9 equals 11x minus 9. I'd go through the process of solving, solve, and I'd get x equal to 4. And then I want to find the length of HJ. Given k is between h and j, so if I plug that in, 44, which would be what, 35? 35. So HJ would equal 35 when I get done here. You can work through that if you want to double check. Oops. Now let's give this one a shot. So here's our setup. Be careful with your picture. Try that out. See what you get. We'll come back and try it out. Okay, so let's double check here. Let's see what's going on. We get M is the midpoint of LP. So I know that's in the middle. And N is the midpoint of MP. So N is right here. Now the only things I know is that LM is 6x minus 4. MP, which is this other chunk, is 4x plus 8. Which means, because I know those are the same, I can set them equal. So that means it's 4x plus 8 equals 6x minus 4. If I solve that all the way, I end up at, what, x equals 12? X equals 6. I want to move down. So x equals 6. So now if I want to plug in and I want to get, my whole thing is that I want to find the length of NP. So I want this, which means it's half of that. So if I know x is 6, plug it in. I get this whole piece here is 32, which means at the very end, NP is 16. Okay, that's it for this video. We'll come back tomorrow and we'll work on some stuff together. Have a great day, everyone.